This is a video for OCR Pure Core Mathematics, Calculus 2, Inverse Trigonometric Functions, 2.3, Integrating using arcsin x. We should already know that if we differentiate the inverse sine, arcsin x, we get 1 over root 1 minus x squared. And a more general result, differentiating arcsin x over a, gives me 1 over root a squared minus x squared. So what does that tell us about integrating using the inverse sine? Well, if the derivative of arcsin x is 1 over root 1 minus x squared, then the integral of the right-hand side, 1 over root 1 minus x squared dx, must be the inverse sine, arcsin x. And this is an indefinite integral, so we need a constant of integration. Similarly, with this one, if I integrate to the right-hand side, 1 over root a squared minus x squared dx, I must get the inverse sine, arcsin x over a, and again plus a constant. And there's that, just tidied up so you can read it more easily. Okay, so how do we integrate 1 over root 4 minus x squared? Well, to do that, I'm going to compare this with my standard form. My standard form, remember, is 1 over root a squared minus x squared. And this looks to be in standard form, but with a equals 2. And that means I can just write down the result that this is arcsin x over a, which is 2, plus a constant. And there's the answer written out for you again so you can read it more easily. Notice that we just write down the result. We don't need to do any other work. Once we recognize it in standard form, we can just quote the result. So what about this one? Well, the issue I've got here is that I haven't got a single x squared. I've actually got 2x squared inside the square root there. So I'm going to need to do a little bit of work to get that down to something with just x squared. I'm going to factor out the 2, and I'm going to take it right the way through and outside the square root. So this thing becomes 1 over root 2. 2 coming through comes out as a root 2. The integral of 1 over the square root of, well, I've taken a 2 out of here, so that's 9 over 2, minus x squared dx. Again, let's compare with the standard form, and my standard form is the integral of 1 over root a squared minus x squared. And this bit of it is in standard form with a is equal to 3 over root 2. And so my integral becomes 1 over root 2, that's copying through from here, and then I can quote the result here, which is the inverse sine arcsin x over a, so it's x root 2 over 3, and that's plus a constant. And again, there it is tidied up. So notice it's not quite standard form because of the 2. We took a factor of 2 out, which became the root 2 on the outside and the over 2 here in the 9, and then that gives me a is 3 over root 2, which we've used here in the x over a. So in summary, you can always quote this standard result. 1 over root a squared minus x squared integrated gives us arcsin x over a. And don't forget the constant of integration if it's indefinite. And if the x squared is not 1, then factor out from the denominator to get it into the correct form. The next video in this sequence is 2.4, integrating using arctan x.